All right, it's great to see so many people and also so many new faces. I recognize a lot of you from last year, but a lot of you are new as well. So before I get to the talk, let me first introduce myself. My name is Ulf Adams. I've been on the Bazel team for 9.5 years. I'm one of the longest members of the team. I'm now here as the professional apologizer. I will say things like, I'm sorry, we thought it was a good idea at the time, and I'm sorry we didn't have the time to do the right solution. I'm a contributor to a large part of Bazel's current design. And time and again, we have learned how Bazel works, or more importantly, how it fails. And so we have made changes to the architecture to improve its correctness and to improve its performance, to make it more correct and more performant. And that isn't to say that it's completely correct and completely performant, but I believe the underlying architecture supports us in achieving goals, our goals around correctness and performance. And for everyone, these goals may look different. For Google, we have very high expectations of correctness and performance, and so we have a monorepo and we check literally everything in. Except for Bash, but everything else is checked in. I'm a contributor to a large number of Bazel source files, so if you look through Bazel's history, you will see my name pop up again and again. And so I answer questions on a lot of things. I'm the former manager of the Munich part of the team. I'm handing off that responsibility to Dimitri, who had yesterday's talk. I'm moving on. I'm told that this is the euphemism for getting fired. I'm not getting fired. I have decided to look at other projects within Google in this space, so I will continue to contribute to Bazel as a part-time contributor, but no longer as a full-time contributor, and not as a manager. But anytime you need help with something, I'm still available. All right, I would like all the Googlers who have working full-time on Blaze and Bazel to raise their hand now, just so that get an idea of the numbers. So thanks. It's over 40 people now, and please give them a big round of applause for it. For all the hard work they have put into fixing my design mistakes. Also, the contributors, everyone who has contributed to Bazel, please raise your hand if you're not a Googler, so that we get an idea of the numbers. I think that's still fewer than team members, but hopefully that will change over time. All right. Yes, thank you. Great. All right, so this talk is about lessons learned. And the way this talk came together was that someone proposed the topic, and then someone nominated me as a speaker. And then everyone contributed notes on what I should talk about. The last changes were just made 2 minutes ago before the talk started. So hopefully it'll work okay. It's going to be about a variety of technical and slightly less technical topics. I'm more of an engineer type. So there's going to be some actual technical stuff in there, but I'm also going to talk about non-technical things. All right. It's a little bit of a mixed bag. I don't have an overview because you would just be confused by how many different things I'm going to talk about. But let's start by talking about Windows. So one of the things that we've learned is Windows is not Unix, surprisingly. So there are like 3 types of differences that we've been struggling with. So file system differences. The path format is completely different from Unix-based operating systems. There is no single root. It's case insensitive. They're not just absolute and relative paths, but there are absolute paths, absolute on the current drive, relative on the current drive, relative to some other drive, extended length, UNC, remote. And this isn't even a complete list. All right. And of course, Windows has this funny DOS heritage where it does path shortening, except if you store a shortened path and someone removes that directory and creates a new one with a different name, it may end up with the same shortened path. And so the thing that you thought it was referring to isn't actually the thing it's referring to anymore. Fun times. But one of the bigger problems that we have with Windows is the path length limit. Now, Windows technically supports long paths, except a lot of tools are still compiled against the short API, and so they have a limit of 260 characters. Now, it wouldn't be so bad if all the developer tools were compiled against the long API, except the Visual C++ compiler isn't. OK. We can work with that. So yeah, let's keep going. Symlink support used to be, well, it was there, except we couldn't use it because it required administrator rights. But we can use junctions at least, so we can create something like directory symlinks, and those work reasonably well, except for like the occasional bugs that we had with them. But I think they're all ironed out now. And of course, then there are the performance differences. And so one of the big things that we've discovered is, creating a process on Windows with create process and wait for a single object takes about 25,000 microseconds. On Linux, a fork and wait PID takes about 2,500 microseconds, which is about a factor of 10 for those who are mathematically challenged. And this is tough. Bazel relied on bash scripts, on tiny snippets of bash code in order to plug some things together. And now if you do that on Windows, you have to start the bash process, you have to start the cat process, you have to start a pipe and whatnot, and you're ending up with like a dozen processes, which is fine on Linux, but not on Windows. And so what we're doing about this is we are working to remove bash from all the critical functions so that you can do Windows builds or builds on Windows without requiring bash. Now, if you want to use bash because, for whatever reason, then you can still do it. But you should be able to organize your source code so you don't have to. And this also applies to the test wrapper script that we're using to run tests, which is doing some test setup, like environment variables and so forth. And we're rewriting that as a native executable, making it a lot faster. Cool. But now, for the Linux and Mac fanboys, it's not like these operating systems don't have problems. All right, too early, crap. Sorry. Forget that. I'll say that again at the end of the slide. There are also toolchain differences. So GCC isn't the standard, Clang isn't the standard. There is MSVC, it's fairly established, everyone's using it. And so we had to add support for that, which we did. It seems to be working pretty well now. There is no standard location for tools, although admittedly on Linux there is also no standard location for tools. Then we have the bash removal, which I already mentioned. Passing arguments to a subprocess turns out to be a little bit difficult because the API takes a single string, and there is no standard conversion API, and everyone's doing it wrong. And even different versions of libc shipped with Microsoft Visual Studio do it differently. So depending on the version of MSVC that your binary was compiled with, you may have to use different quoting rules. Sorry, we can't pass an empty string to a binary on Windows. It's not possible. All right, so now for the Linux and macOS fanboys, not everything is rosy on these platforms either. So I have some funny examples that I want to briefly talk about. So on Linux, multi-threading is awesome. We had a bug in Bazel where we accidentally created like 70,000 threads in a couple of seconds, and it worked just fine. Until we ran on a machine that had a limit of a couple 100,000 threads, machine-wide limit. And when we run like a couple Bazel instances in parallel, suddenly things start breaking because, well, not every tool is prepared for not being able to create a new thread. Or let's say no one is, including Bazel. And so things start crashing on this machine, and we had to go and fix it. Syscall performance is really good. There are a lot of people contributing to Linux, a lot of large companies contributing to Linux, including Google. And so the performance is really, really good. The bad on Linux. File names are arbitrary 8-bit strings. This, UTF-8, Maybe, maybe not. We don't know. Okay. And the worst part about Linux is fork exec is inherently racy. So when you fork, you create a copy of the file descriptor table, and then you try to close the file descriptors as fast as you can, and then you exec to the subprocess. Now the problem is, if you happen to copy it, all right, now it's getting complicated. Sorry about that. One thread writes a file to disk and marks it as executable, and then goes to execute it. Another process comes in, forks just before the execution, and still has an open file handle to the executable. Then the first thread tries to execute it and fails because there is still an open file handle to an executable file, and that's not allowed for security reasons. Okay, so you add a loop and try again. macOS multi-threading is terrible, and one of the things that we've been doing is try to reduce the number of threads as much as possible. And in the future, we will have to have stronger, in Bazel overall, we'll have to have stronger caps on how many threads we're creating. We're not there yet, but if you look at the commit history, you will see changes happening. And macOS, funnily, also ships a lot of very old GNU tools. So you often have to look at the macOS documentation to get the flags right. The ugly part about macOS is file names are normalized UTF-8. Well, now, they're shipping a new version of macOS. The new Apple file system doesn't do this anymore, but the old macOS was still doing it. So they were normalizing the file names as you wrote the files. So it could happen that you write a file and you try to open it with the same name and it doesn't work because the file system normalized the name. Yeah. The other fun part is you can't run two iOS simulators in parallel on the same machine, except if you're using VMs. Ah. All right, Windows I already covered. The create process API is actually pretty decent on Windows, so I chalk it up as a win for Windows. All right, let's talk about external devs. Complete turnaround on topic. This is completely different, nothing to do with Windows. I mean, not specifically. All right, so history, when we made before the open source release, let's go back a little bit more in time, we don't have any external dependencies. We have a monorepo at Google, everything's checked in. So we released Bazel, and we knew this was going to be a problem. We didn't know how much of a problem, but it quickly turned out it was a big problem. All right. And so we started adding some APIs and some mechanisms to fix the worst problems, except that it wasn't really thought through. And you can blame that on me. It's my fault. I didn't do proper design reviews. And of course, adding local discovery adds a big hermeticity loophole, which is now turning around to bite us when you try to do remote execution. You first have to make everything hermetic. So that makes it harder for people to move to remote execution. What are we doing about it? At BazelCon last year, we started to have a lot of discussions around this. We've basically do a reboot, trying to find principled solutions to the underlying problems that we've identified, like file system layout, diamond dependencies. We are deprecating the built-in workspace rules. Please look at the documentation. It's linked from here. If you're using the built-in workspace rules, please migrate to the new ones. Not all of them are deprecated, and some of them are going to stick around, but some of them are deprecated. Cool. All right, next topic. Again, completely different. Automated dependency management. And what I mean with that is you have your source files, and your source files, you have imports in Java or imports in Python or in Go. And now Bazel is forcing you to repeat those import declarations in your build files. Yes, I hear you. We hear you. It's a problem. There are multiple, more or less, working tools for this, for depth management. There are literally dozens of different tools at Google. For some languages, there are even multiple tools for the same language. None have really achieved critical mass, except for Go and maybe TypeScript. None are completely correct, except for Go. at least used to be correct. Go is now introducing changes to the language or to the way they handle third-party dependencies that may make it more difficult to write correct tools for automatically generating the build files. But there are Go experts here, and so they may be able to answer all the questions about that. And this is how Buildifier and Bulldozer came into existence. So the Go team at Google decided they wanted to do this, and they wanted to automatically modify build files. Now, when you do that, and you have like completely haphazard like syntax, and some people do the new line here, and some people here, and it's all mixed up. Then if you put a tool there that automatically goes and tries to fix up the build file, how should it format it? Should it like try to follow the formatting, or should it, Anyway, they decided to write Buildifier and write a library to parse build files and do auto formatting. And so we have basically taken that over, at least the basic library, and that's the basis for a number of these tools that do depth management. All right, now what are we doing about it? Not much yet. So we know it's a problem. We will work on it. We commit to work on it. We know it's a big problem for a lot of you or your users, but it's also a difficult problem. And there are like a number of competing things, right? You want it to be good enough so people can use it, but making it completely correct is really hard. So for Java, for example, your classes can be anywhere in your source tree, and they don't even have to have the name that the class is having at the end. So you can't just look at the file names. You actually have to parse the source files. And then you may have multiple classes with the same name on your class path, which you shouldn't, but you have anyway. So and this is also up to you. How can we help with experimentation in this space without too much disruption? And ideally, without adding APIs that then turn out to be design flaws. All right. Completely different topic. Let's talk about Blaze and Bazel. And at last BazelCon, I was asked a lot of times, what's the difference between Blaze and Bazel? And here I'm using the word fork to exaggerate the differences. I don't actually think the differences are all that big. I haven't. We've been, all right, history, let's go through history first. Our workflow to this day, and starting from the initial release and to this day, is that the source of truth is our internal repository, which is called Google 3, and we copy to GitHub. If you actually manage to force submit something to GitHub, it would be overwritten by the next export, which is also why we can't just merge changes on GitHub, unfortunately. We also, when we open sourced Bazel, or Blaze at the time, we open sourced a cleaned up Blaze. Yeah, I know why we did it, and I'm not sure we made a mistake there, but it's also caused problems. And it has introduced gratuitous incompatibilities that makes it actually harder for Google itself to use Bazel, and for Googlers to open source code or to pull code back into Google that has been open sourced. So that's not ideal. We've also not really completely cleaned up the interfaces between what's external and internal. And we've actually run an experiment for a while where we sort of had a check on every submit, whether it was touching only open source files or open source and closed source files. Yeah, almost all the commits touch both at the time. I think things have improved since then, but I don't have the data to prove that. And then we also didn't open source all of the tests. I'm sorry. OK, what are we doing about it? We are removing differences. We're actively removing differences. This is difficult. If you consider build files a client of an API, we have literally hundreds of thousands of clients. And so anytime we want to make a change to the build file API, we have to go in and update hundreds of thousands of clients. And of course, we can't just break it, because if Google search can't do release anymore, then we roll back. There's no question there. All right, so a few things that we have done. Problem with the mic. Ha. We removed CPP semantics, the external parts. CPP semantics is still in use for Objective-C, but the most egregious parts of it are removed. And the parts that are left are all open source. So, yes. We just open sourced the code for include scanning. It's not in use yet, but I pushed a change last week that made it all open source. We are removing, when we open sourced it, we forked all the build files. So we have a build and a build.oss file. And unfortunately, that means any time we accept a patch that modifies a build file, we have to copy that modification to our internal build file. And now, the other fun part is that, of course, these build files have diverged. So they are no longer in complete sync. So you can't just copy the patch to the other build file. And then, again, we have put a process in place that allows us to remove the internal build file, to merge the two build files into one, so that there's only a single build file, and so we can just cleanly apply a patch. We haven't moved all build files to this new mechanism yet, but I hope the Bazel team is listening and will do some work. Everyone, I see you. We've also introduced the build event protocol, which is replacing like a multitude of internal mechanisms to communicate machine-readable data to other processes that want to use and work with Blaze and Bazel. And this is completely open source. There are no hidden parts. It's all there for everyone to use and enjoy. We are removing code. We are going through the Skylark migration of all the built-in rules. And some of them have already been migrated, and you may not see that because some of the rules are internal, and so we've migrated internally from built-in code to Skylark. There are deprecation, we have gone through a deprecation. We're going through an active deprecation of Google-only features. We're going to deprecate what we call the master log. If you don't know what that is, that's great. You don't have to. We're deprecating Blaze Analyze. Sorry, TypeScript team. They're using it internally. They're currently migrating to use Query directly, which is like a lower-level API. And also GWT rules. GWT is, anyway. We're also getting better at publishing our design docs. If we're still not perfect at it, please hold us responsible for doing that. Eventually, so we are committing to eventually move to an external first flow. When that's going to happen, I don't know. But they're the guys you need to complain to. Stability, and I'm repeating some of what Dimitri talked about yesterday. Things break too often, flags change all the time, they're incompatible with Starlark, API changes, there are build event protocol changes, there are incompatible changes to the built-in rules. Stability is hard, and we've been discussing this for a long time. What is actually an incompatible change? What properties of the API do we guarantee, and what properties of the API do we not guarantee? And so this is where something comes in that we call Hiram's law. With a sufficient number of users of an API, it doesn't matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. With other words, the more successful we are, the harder it is to make a change without breaking someone somewhere. Yeah. So maybe you remember George asking yesterday about action keys. The problem with action keys is we made some changes to make them faster to compute, but that changed the actual value of the key. And so for his setup of his remote execution system, when you do that, basically the new version comes in and everything gets rebuilt because the keys are different. Now, you can solve that by creating a larger cache, except that you need like twice the amount of storage in order to be able to handle that kind of change. Not ideal. So what are we doing? Well, we are doing the things that I already mentioned. We're reducing the API surface as much as possible. We're migrating the built-in rules to Starlock. Now that doesn't magically make them more stable, but we can provide a baseline of stability guarantees for the Bazel binaries because we don't have to cover such a big API service anymore. Now, the question is, what happens to you, right? You don't just want to use Bazel Core. You don't just want to, I mean, maybe you do. Maybe some of you only use Bazel Core and have all their rules written, home written. But most of you do want to use existing rules that other people are maintaining. And so, how's the contract there going to look like? And we're actively deprecating legacy APIs. And going forward, we will more aggressively use known mechanisms to provide backwards compatible APIs or to make backwards compatible changes. We're using protobuf extensively. Protobuf has a strong stability. Well, it doesn't magically make things stable, but allows you to establish a process where you know exactly which changes are stable changes and which are not backwards compatible. We're going to more aggressively add new APIs and then deprecate the old APIs instead of just going, here's a new one, sorry, the old one is gone. And that sort of thing. And to that end, we're introducing a common process for making these incompatible changes. We want Bazel 1.0, but we also don't want to slow down the development of Bazel. And that's a tricky path to walk. The intent of the new process is to provide a migration window for developers and users to work with the new behavior. And to some extent, this will have to be trickled down kind of thing, where we start to add the new features, and then we give the rules owners time to adapt the rules to the new changes, and then the users more time to adapt to the rules changes and to the core changes. How large is that window going to be? Well, let's start somewhere. Let's start with one release. One release actually means, at least 2 releases, right? You can't just. You need to start adding it, and then you need to, flip the flag that enables the incompatible behavior sort of as a soft break, so that people can still flip the flag back and get the old behavior, and then have time to adapt to that. Or something along those lines. To some extent, this depends on the exact change that we want to make, and we have to leave some leeway to the author of the change to decide how exactly to roll out the change, to decide exactly what constitutes an incompatible change. How large is the impact going to be? Is it we're only making a small change to sandboxing? Yes, there is someone who's going to depend on this, but this is just small enough that it's okay. And to some extent, we rely on you to give us the feedback. No, this isn't okay because we have 200,000 projects that depend on this behavior. We're also excluding features marked as experimental. As Dimitri said yesterday, don't use experimental features. Let us know when try them out by all means, but avoid them in production and let us know if you need them so that we can push the process of making them not experimental forward. Now, what does that mean for you? There are some implications for you as developers and as contributors. You need to work with us, and you need to let us know if we make mistakes, right? We're not perfect, you're not perfect, we're all not perfect. Hold us accountable for keeping to the process. If we make a large change and it didn't work, you have to give us that feedback. The process also applies to your Bazel contributions. So if you're making a Bazel change, you will also have to go through the same process. And that means if you need to make an incompatible change, it will require a sustained multi-release effort. That's a price. The contribution process. All right, completely different topic. We could be better. We got your feedback. We all watched George's talk yesterday. You're absolutely right. You're absolutely right. We have too many delays on reviews. We have too many delays on bug reports. We have too many delays on discussions. We have breakages on hidden tests. We have unclear ownership of components. And of course, there is this specter of it being completely Google controlled, which I don't personally think is a problem, but I understand that it's a problem for our users. Scaling up is hard, and I'm making excuses a little bit, okay? I'm making excuses. The Bazel team is over 40 engineers. Not all are exclusively working on open source code. We're increasing the amount of open source code over time, but it's not completely open source. We have recently reorganized our efforts around community support and CI maintenance. Hopefully, you have already seen that get a little bit better. Hopefully, it will get better over time. We're looking at coming up with a clear component ownership model. We were thinking about adding owners files to subtrees so that you know who to send a patch to. We will open source more of our tests. We commit to open sourcing more of our tests. Maybe in time for 1.0. What do you think? So if you aren't getting replies, if things aren't happening, if there is silence, there are specific people on the team who are the managers of the team internally and who are committed by Google to making sure that this works. So CC Dimitri or John or me, if you would rather have me help out, if something is not working for you. Thank you very much.